Logan? Logan?
Yes.
I'm having troubles. What should I do for my physics project?
I don't know.
Mother, I'm so confuzzled. What should I do for my physics project?
I don't know.
Brielle, what should I do for my physics project?
I've always been fascinated by Frisbees.
Hello everyone, Emily here. Today on Fabrics of the Cosmos, episode 5, Fantastic Physics Fun with Flying Frisbees, we are going to answer the question, why don't Frisbees follow kinematic equations?
So I know what you're all wondering, how did these kinematic equations come to be? Well, it all started in 1865 with a young lad named Isaac Newton.
He was sitting under a garlic tree contemplating life, and a garlic clove fell on his head.
Right there, that's when he had the idea, and he created all of the kinematic equations just because a garlic clove fell on his head.
So Brielle, you were telling me that you had something to prove with Frisbees for physics, right?
That's correct. We're going to prove that Frisbees cannot be predicted by the kinematic equations.
So is it just a Frisbee thing? Like, Frisbees are the only one that don't follow the equations?
Basically.
Alright then. Well, how are we going to do this?
So we're going to take a Frisbee and we're going to take a ball and we're going to throw them with the same velocity, and if our experiment proves right, then the ball should land in a different spot than the Frisbee.
So you're saying the Frisbee won't go up and down in a perfect parabola?
That is correct.
Alright then, let's get to it.
Okay, now that we have these videos of the Frisbee and the ball, we need to refine them so that we can gain the information that we need for the kinematic equations.
It's time to get cracking.
Alright guys, so we're like day 2 into figuring out how to make the videos work for our kinematic equations, and some of us are getting a little tired, so I decided to make some hot chocolate for us. As you can see, we've got it in this #1 scientist mug, and I'm gonna go give it to Emily now, so let's go. Hey Emily, wake up. Wake up, Emily. I made you some hot chocolate.
Thank you.
Yeah, no problem.
What were we talking about again?
Kinematic equations.
Oh, right. Delightful.
Alright guys, so I'm going to show you what we have done with the videos that we took. So we took 3 screenshots of all of the videos of the Frisbee and the ball, and we took screenshots at the beginning, the vertex, and the end. So here's our first Frisbee, and you can see that we took a screenshot as the Frisbee is leaving my hand right here. The next one, we have a screenshot of the Frisbee of this Frisbee right here at the vertex, and then we have the ending of the Frisbee, and we put dots on we put points on all of these so that we can graph our parabola later. And I'll show you we have the same thing for the ball. So at the beginning when it's leaving my hand, and then the vertex, and then we have the ending. And so using Desmos, we have created parabolas for all of these. So here's the parabola for the Frisbee. As you can see, It goes like a parabola. And then we have the parabola for the ball, and it is also a perfect parabola. And so now I'm going to show you if we add a point into the Frisbee parabola, which is going to be 1.5, and this is the ending of where the Frisbee was, and then it's going to be negative 1.9. So if we add that into our equation, then, one second. Oh, I need to make this higher. Okay. So, as you can see, the parabola has now been changed so that the vertex is here, but as you'll see, I'll show you that in this Frisbee, the vertex of the Frisbee is actually, oh, one second, I got to find it. Okay, you can see that the vertex of the Frisbee is supposed to be here. So this proves that if you use the ending of the Frisbee, it doesn't give you an accurate parabola, and if you take away the ending of the Frisbee, as you will see, then you get an accurate parabola, which means that the Frisbee ended here, but it should have ended somewhere in this area.
So you see in the horizontal displacement box, there's the dx, and that is the displacement, and that's what we were trying to find out. But in order to find the displacement, you see, we need to have the initial velocity as well. The initial velocity is the meters per second. But the thing is, we have the amount of time the Frisbee has been traveling through the air, but we don't know how many meters it has been traveling, because that is what we are trying to find by finding the displacement.
Okay, I'm going to explain to you why a Frisbee cannot be predicted by the kinematic equations. So you see here how it has an open space, and this Frisbee is pretty light. So when you throw it, the air goes underneath the Frisbee and lifts it up, so it stays in the air longer than it should. Also, it tends to spin, and when it spins, it turns like this, and then when it's turning this way, the air is no longer lifting it up, so it drops dramatically, and that is why a Frisbee cannot be predicted by the kinematic equations. So we learned that although Isaac Newton made many major discoveries in his life, there's still more to learn in this world.
So tell me, Brielle, not everything in life goes perfectly. So how did your experiment end up so perfectly?
Well, it didn't, Emily. That's what happens. We have to bring in something called assumptions. And so assumptions are basically where you have to account for errors in your math and sometimes human errors. So let me explain some of the assumptions that we had to make in this experiment. First of all, we had to assume that I threw the ball and the Frisbee at the same velocity. And we know that they're probably not going to be exactly the same, because that is very hard for a human to do. If we had a computer, that would have been, or a robot, that would have been a lot better, and it could have been a lot more accurate. And we also had to assume that we put the points on our graph at exactly the beginning vertex and the end. And so we had to assume that those are perfect, even though there's some human error involved in there.
So did you have to assume that there was no air acting on the object at all?
Yes, that's exactly what the kinematic equations do. They don't account for the air that is very real, and so we had to assume that the air was not acting on the ball or the Frisbee. And as you can see in our experiment, that sometimes assuming makes everything not work out very well.
Because air did act on the Frisbee.
That is correct, Emily.
All right, any other assumptions that you made?
I can't think of any right now.
All right.
Okay guys, I'm glad you joined us on this documentary, and I hope it helped answer some of your questions you had about kinematic equations.
It certainly helped me.
Okay, we'll see you next on the next episode of The Fabrics of the Cosmos, where we answer questions like, why do sharks swim?
And why does my grandmom get old? I don't know what to do for my physics project. Do you have any ideas? The moment has come.
See this later.